our pieces and what we're dealing with and what we're solving for and what angle are we looking at. And using what pieces we have, we can use trig and trig functions, whether it be in a calculator or any sort of trig calculation tool you may have, and come up with missing sides or missing angles. In this case, I actually left out the hypotenuse, so maybe I would use my a squared plus b squared equals c squared Pythag to come up with this hypotenuse of 15, but we're not doing Pythag today, so we'll just leave that. But that's a way. Now, the first thing that needs to be done is we first need to determine which angle we're talking about. And that's important because the angle that we designate that we're going to be using is going to designate what is our opposite and what is our adjacent. The right angle is always going to be the same. This will always be our hypotenuse. And and if we look at it from the angle of, okay, well, let's say we look at this angle, it's important because things change and now this becomes our opposite and this becomes our adjacent. So it is important to decide which angle are we talking about, and that helps us determine opposite and adjacent. So if we're just looking at this triangle alone, we have our, what you may hear many times is we have our SOH, SOH, ka, toa, and that's probably like a, I don't know, maybe a hundred. I'd have to look into that. Maybe 100-year-old way of remembering where where does opposite go when you have sign or we use an opposite. Where do all these pieces go? And that's a way to remember. And basically all you're doing is just setting up. Well, off of my theta, my opposite is 9 and my hypotenuse is 15. You may need to reduce this to a 3 over 5, but for the most part, this is the ratio, the trig ratio. It is important to also understand that trig is a ratio, and they use that ratio, or the calculation uses that ratio to come up with your missing sides or missing angles. Now, cosine of this theta here, this is again the side that is connected to the vertex of the angle we're talking about, and it is the one that is not the hypotenuse. Our adjacent is 12 and hypotenuse is 15. And then our TOA, that's just simply our opposite. Again, you may need to reduce these in some cases. This is our 9 over 12. And that's how we come up with some of our trig ratios, our basic sine, cosine, tangent. And we use this SOHCAHTOA as a way to just kind of remind ourselves what pieces are what. Now, you do have your trig inverses. And what that is they're taking all of these and basically making it an inverse, whether it be 1 over sine, 1 over cosine, or 1 over tangent. Those are your inverses here. And you could go through the whole process of saying 1 divided by my opposite over hypotenuse, which is 1 really multiplied by my hypotenuse over opposite. But we're just going to go ahead and say, okay, really our inverses are just, let's say, the upside down version of our sine. Now, the problem I had in high school is always trying to remember, is secant cosine or is cosecant? What I came up with to help is if you look at secant and you take the E and you make it an O right here, like this, it kind of looks like cosine backwards. So that's kind of how it, now if I know that that's the cosine, then I can go ahead with the cosecant. And basically all you're doing is taking an inverse, 15 over 9, 15 over 12, and 12 over 9. It's just an inverse of your, and we'll get to why and how we're going to use those. But for now, it's just basically this idea of what are my trig functions, what are the ratios, how do I set them up, how do I find the pieces, and and what angle am I working with? So welcome back to Swell Academy. Today we're talking about trigonometry, aka trig, as I and many like to call it. And this is an idea, just not a basic idea, but an overall idea of how can we look at the relationship of a triangle, its right triangle, a Pythagorean theorem, a circle. How can we look at all this and come up with a relationship in which we can look at an angle, in this case, theta, which is a very common term used to describe a certain angle. How can we use this idea of drawing a triangle within a circle and coming up with certain measurements, aka the hypotenuse, the side opposite the right angle, the opposite side, the side opposite our theta angle, and the side adjacent to or connected to the angle that is not the hypotenuse. That's just basically basic pieces, basic ideas. What we're looking at, big picture, trig. Now, the first thing we need to do working with trig is identify, when we look at, like we did, we looked at the theta here. When you look at something different or a different angle like delta here, once that happens, the thing we want to identify is now this becomes the opposite. Where in the previous triangle, 9 was the opposite, and this becomes the adjacent. And again, we always have our hypotenuse here, and we're just working from a different angle this time around. We have the 12 over 15. We have the 9 over 15. We have the 12 over 9. And then these all just flip, 9 over 12, 15 over 9, and then the 15 over 12. And again, yes, you may have to or should in most cases reduce these as such appropriately, because you're thinking of it as a ratio. So you're trying to say, in this case, you're trying to say that my ratio of hypotenuse to adjacent is 5 to 3. So you want to represent it in its simplest form. So just a few basics, general idea of what we're dealing with trig and how to identify parts, and help us leading forward into eventually solving for our theta, solving for our delta, or using an angle measure, let's say 47 degrees, and coming up with, okay, what's my opposite side? That's the intention here. That's our goal. Hope this helps. Remember, the more you fail, the more you succeed, so keep working hard.